Hey guys, it's Miss Johnson, and I'm here to bring you our notes video for Unit 4 Notes 1. Today we are kicking off Unit 4, which is on factoring expressions, and we're going to start by looking at factoring out the GCF and factoring by grouping. So you're going to hear the word factoring a whole lot in this unit, and we're going to talk a lot about what factoring actually means. Before we get into that, I want us to just think back to Unit 3 a little bit and remember what happened when we had expressions like this that we were supposed to simplify. So up at the top, it says simplify the expression. This 3x squared out front of this set of parentheses with a trinomial behind it, we need to distribute that 3x squared into all three parts. That gives me 12x to the fourth minus 9x to the third plus 6x squared. So remember that when we're distributing, we're multiplying. Multiplying coefficients is just putting 3 times 4 together. Multiplying powers or multiplying variables that have exponents means we add the exponents. 2 plus 2 gave me 4, 2 plus 1 gave me 3, and 2 plus 0 gave me 2. So distributing that throughout and finding the product after we take care of that multiplication. In this one, 4x to the third times 3x squared, that's 12x to the fifth. 4x to the third times negative 2x, that's negative 8x to the fourth. And 4x to the third times negative 1, negative 4x to the third. So again, we're multiplying when we're distributing there, and then adding the exponents when there are powers. Now, we are going to talk about actually factoring these things, and factoring these things is actually kind of undoing the multiplication. It's undoing what we did a lot in Unit 3. And the first type of factoring that we want to look at is just taking out the GCF. Now, hopefully you've heard the phrase GCF before, or the acronym. It stands for greatest common factor. The greatest common factor is the largest factor that can be divided out of each term. And the greatest common factor may have numbers and variables within it. So we're undoing multiplication when we're factoring. We are taking apart a product. So if I want to factor out the GCF, I first need to figure out what the GCF actually is. Then I need to take the GCF out of each term. And then I'm going to write the expression in factored form, which means I have the GCF out front and then multiplied by the terms that are left over grouped together behind it. So we're going to start with that product and we're going to take it apart into its factored form. So let's take a look at how we do that. If I look at number 3, I have 12a to the second plus 16a squared, and I want to write it in factored form. The first thing I need to look for is what is the GCF. So just off to the side here, I'm going to make a note to myself of what the GCF actually is. So think about the largest factor that can come out of both 12 and 16. The largest number that can be divided out of 12 and 16 is 4. But then I also need to look at the variables. Here I have a squared and there I have a. So I can take out an a from both of those. A can be divided from a squared and a can be divided from a. So that's my GCF. That's what I'm going to divide out of both of these terms. I'm taking the same factor out of both, which is where the common comes from in greatest common factor. I'm taking the same thing out of both parts. So I'm going to write that GCF out front of my simplified or my factored expression, I should say. And then I want to figure out what's left over. So now actually do this division. Take 12 divided by 4. That gives me 3. A squared divided by a to the first. I can get rid of one of my a's and that leaves me with a. So I have 3a in the first term. Second term, 16 divided by 4 is 4. A divided by a cancels out, so I just have a 4 left over. So my GCF is out front, the factors left over are behind, and that is my factored form. It looks kind of funny because we look at something that has parentheses in it and our brains automatically want to put that distribution back in and take care of that. But if I'm factoring things, I'm undoing multiplication. I'm taking apart a product. So I'm taking a product and I'm separating it into the parts that were multiplied to get it in the first place. So it's kind of a little backwards. We have to think backwards when we're in the factoring unit. Let's take a look at 5x plus 30y. So again, I'm going to start by finding the GCF. So just off to the side somewhere, make a note of what the GCF of these two terms might be. I have 5x and 30y. From 5 and 30, I can take out 5. From x and y, I can't take out anything. X and Y are two different variables. It's like apples and oranges. I can't divide out a common variable there because there's no Y in this term and there's no X in that term. So the variables I just have to leave alone. So my only GCF here is a 5, and I'm going to divide it out of both parts. I write that GCF out front. 5 divided by 5 goes away, and I'm left with just X. 30 divided by 5 is 6, and I'm left with 6Y. So GCF out front, whatever parts are remaining behind, that's my factored form. You can always tell if you've factored it completely if there's no like terms or there's no common factors left inside the parentheses once you're finished. So that x plus 6y, there's nothing common between x and 6y that I can divide out. So I know I've gone as far as I can. Let's take a look at number 5. 18cd to the squared plus 12c squared d plus 9cd. So I first want to identify what that GCF might be. From 18, 12, and 9, I can take out a 3. I can divide 3 out of all of those. From the cd squared, c squared d, and cd, I can take out c to the first and d to the first. Because over here, I don't have anything raised to the second power. Here I don't have a d to the second power there. I don't have a c to the second power, so I can only take it out to the first power. So that's my GCF. That's what I'm going to divide out of each part. And then I take a look at what's left over. So my GCF gets written out front. Behind it, 18 divided by 3 is 6. C over C goes away, and D squared over D, I can get rid of one of those. So I have 6D. Then 12 divided by 3 is 4. C squared over D, I can get rid of 1. D over D is gone, so that's 4D. And the last one, 9 divided by 3 is 3. C over C cancels, D over D cancels, so just plus 3 behind there. Oops, that's supposed to be a C there, sorry. Fix that, there should be a 4C. There we go. C left over. Check the insides. 6, 4, and 3 don't have any like terms. That has a D, that has a C, that's a constant, no like variables. So that's it. Take a look at number 6. In number 6, 3x squared minus 2x plus 1. And I want to look for the GCF here. So if I look at 3, 2, and 1, I don't have anything in common other than 1 there. So 1 is a GCF. Then I look at the variables. Here I have an x squared. There I have an x. But that's just a constant. I don't have an x with that term. So I can't actually take an x out of all of these because I don't have an x with the last one. So the only GCF here is 1. And dividing by 1 is easy because nothing changes. I just have a 1 out front. 3x squared minus 2x plus 1. And really, there's nothing else that we can do with that expression. Let's flip it over to the back and talk about factoring by grouping. So now factoring by grouping is undoing multiplication and distribution. That we've been talking about since the beginning of this video. So we're undoing multiplication and distribution. We're taking apart a product. That's what's happening here. So factored form is when we write the expression as a product of its factors. And the factors, sometimes the factors may be the same, or sometimes the factors may be binomials, meaning there are two terms. So just looking at what factored form actually is, we're taking apart the product, we're undoing the multiplication, and we write it in factored form when we have those factors multiplied together. Sometimes our factors are binomials. Now here's our steps for factoring by grouping. So when we're factoring by grouping, we're looking at things that have 4 terms. And the first thing that we want to do is group terms into 2 groups of 2. So group the terms into 2 groups of 2, and we're just going to use parentheses for that. I'm going to have you write down these steps first, but then we're going to do 6 examples together, so you're going to see lots of examples. Then, after we split them into 2 groups, which is why it's called factoring by grouping, we're going to take the GCF out of each group. So figure out what the GCF is in the first group, figure out the GCF in the last group, and divide it out. what we have left should match. And we're going to take a look at what that looks like. But whatever we have left should match. We write the leftovers as one of the factors, and we write the outside GCFs as the other factors. So again, we're going to do lots of examples together and see what this looks like. So steps to factoring by grouping. We're only factoring by grouping when we have 4 terms. Which is why the first step is 2 groups of 2, because 2 groups of 2 terms makes 4 terms. All right, let's take a look at number 1. So I have x squared plus 2x plus 4x plus 8. So here are my 4 terms. 1, 2, 3, 4. I'm going to group these things into 2 groups of 2. So I'm going to put the first 2 in parentheses and the last 2 in parentheses. There's my first step. Now, I want to find the GCF of both of these. So the GCF of this one, if I look at this, the only thing that I can take out of x squared and 2x is an x. So if I write that out, I have x. Behind that, I'm going to be left with x plus 2. Over here, the only thing I can take out of this one is a 4. This is plus in the middle, so I have plus 4. And then 4 divided by 4 goes away. That's x. 8 divided by 4 is 2. Now check. Look at what you have left over. The leftovers are inside these parentheses, and if we have done our factoring by grouping correctly, they should match. So I have x plus 2 and x plus 2. They match, so I'm good. Now I need to actually write out the factored form. So one of the factors comes from the GCFs that we took out. That factor looks like x plus 4. I take the x and I take the positive 4, make it x plus 4. That's one of my factors. The other factor comes from the leftovers. The leftovers make another factor. So I have x plus 4 as one of my factors, x plus 2 as another factor. These two things are being multiplied. Now you're not going to see me write that little multiplication dot in between them, but I want you to recognize that they're not being added, they're being multiplied, because what we've done here is take apart the multiplication. So these two factors, here's one factor, here's another factor. I took apart the multiplication, that's my factored form. If you're confused and looking at this, like how in the world did she go from this set of 4 terms down to these 2 binomials? Let's think about foiling that back. If I FOIL that back, first times first is x squared, outside x times 2 is 2x, inside x times 4 is 4x, and last 4 times 2 is 8. There's my 4 terms, x squared, 2x, 4x, and 8. There they all are. So I get back to the same expression that I just took apart when I FOIL it back together. Now, in this unit, we're practicing how to take apart that expression because we're going to be using that when basically in everything else we do in math for the rest of this year and in your future math career. So you're going to need, there's going to be a lot of times where you need to undo a product or take apart a product, in other words, a factor. All right, let's take a look at number 2. I have 4 terms here. I'm going to group the first 2, group the last 2, and then I want to look for the GCF. In the first group, I have a GCF of 11 and x. I can take 11 out of both of 11 and 33, and I can take an x out of x squared and x. So I have an 11x out front, then actually do that division. 11 over 11 goes away. X squared over x is just x. So I just have an x left over. The second term, 33 divided by 11 is 3, and x over x goes away, so that's minus 3. And it's minus because there was a subtraction sign in between. Look at the second group. I can take out a 10 from both of these. So I have plus 10, and then 10 over 10 goes away, leaves me with x. 30 over 10 is 3, leaves me with minus 3. And take a look. X minus 3, x minus 3. Check that out. They match. So one of my factors is the outsides, and the other factor is the insides. And again, when we write it in factored form, these two things are being multiplied together. So I write them right next to each other in their own sets of parentheses. Let's try again. 2x squared plus 5x plus 4x plus 10. Now some of you may be looking at this and saying, why don't we take that 5x and 4x and put it together? They're like terms. Well, when we're factoring by grouping, we want 1, 2, 3, 4 terms. So it doesn't help us to take these two and put them together, because if I made it 2x squared plus 9x plus 10, how do I group them? Do I group the first two? Do I group the last two? That doesn't make any sense. So factoring by grouping, we want to have 4 terms. So while our brains may say, oh, take the like terms and put them together, think factoring is undoing. Factoring is taking something apart, pulling it apart into separate factors. We're not putting things together here, we're taking them apart. So I'm going to group the first two, group the last two, and find those GCFs. From 2x squared and 5x, my only GCF is x. So if I divide by x here, x squared over x is just x. I keep the 2. 5x over x, that goes away. I keep the 5. Now 4x plus 10, the only thing I can take out of 4 and 10 is a 2. So I have plus 2 out front, and it's plus because there's a plus in between. So plus 2 out front. 4 divided by 2 is 2. So that's 2x left over. And 10 divided by 2 is 5 plus 5. 2x plus 5, 2x plus 5. X plus 2, 2x plus 5, and that once again comes from outsides make one and the insides make the other. All right, let's try number 4. So in number 4, I have 8r to the third minus 64r squared plus r minus 8. So I'm going to group the first two, group the last two. From the first two, GCF. Oh, sorry, I should have circled my answer over here. This is my factored form of the expression. Number 4, so the only thing I can take, or the things that I can take out of the first group, there's actually a lot I can take out of the first group. I can divide by 8, because both 8 and 64 have a common factor of 8. And then r to the third over r and r squared, I can actually take out an r squared there. So r squared comes out of both of these. And let's take a look at what that leaves me with. So 8 over 8 goes away. R to the third over r squared leaves me with just r. So my first term is r. 64 over 8 is an 8. And then r squared over r squared cancels. So I'm left with just minus 8. Now this r minus 8 over here, there's not actually anything that I can take out of this pair except a 1. And I do have to represent that 1. I'll talk about why in a second here. So I have 8r squared plus 1 and r minus 8. So that's my factored form. Now, if we wouldn't have represented that 1 as a GCF, so that 1 is actually the greatest common factor here. It just seems silly because it's not changing what's left over on the inside. However, if we didn't represent that GCF, we would have lost those terms that you multiply the first and the last, or the inside and the last. So if I think about foiling this back together, I go first, which is 8r to the third, outside, which is negative 64r squared. And if I didn't have that 1, I wouldn't have anything to do inside and I wouldn't have anything to do last, so then I'd lose those last two terms, and that doesn't help me. That's not what I'm looking for here. So I have to represent the GCF of 1. That's why I keep that 1 as part of my factored expression. Let's look at numbers 5 and 6. So in number 5, I have 6v to the third minus 16v squared plus 21v minus 56. So I'm going to look for the GCF first. In the first group, I can take out a 2v squared. That's 2v squared. When I do that, 6 divided by 2 is 3, so I have a 3. And then v squared, or v to the third over v squared, I can take 2 of them away, leaving me with a v left over. Oh, sorry, I didn't write my GCF out front. That was silly. Let's try that again. So I have 2v squared as the GCF. That leaves me with 3v. Second term, 16 divided by 2 is 8. V squared over v squared goes away. So minus 8 there. Over here, 21 and 56. Hopefully you can think of these common factors, but they're probably a little more challenging. 21 and 56 actually have a common factor of 7. I can't take a v out here because I don't have a v with the 56, so 7's my GCF. It's a positive 7 that I'm taking out, so plus 7. 21 divided by 7 is 3, and I keep the v. 56 divided by 7 is 8. There's a minus sign in the middle, so minus 8. Insides, they match, yay! So outsides become 1. Here's one factor, 2v squared plus 7. And the insides become the other, 3v minus 8. Some of you may be asking, I wonder if it matters what order I write these two factors. And the truth is it does not. So you have 2v squared plus 7, 3v minus 8. This is just really like an x times a y, which we all know is the same thing as y times x. So if I flipped those and did 3v minus 8 times 2v squared plus 7, I'm really getting the same answer there. It does not matter which order you put your factors. You can put the other one in front and the other one behind because I can flip multiplication. If I flip multiplication, I get the same answer. So let's take a look at number 6, last one. So 40ac squared plus 25ak squared plus 32bc squared plus 20bk squared. Ooh, a lot of factors there. So group and group. And the first thing that I want to do is look for a GCF in the first group. From 40 and 25, I can take out a 5. Then take a look at the variables. So there's a lot of variables going on in here. Here I have an a and a c squared. Here I have an a and a k squared. The only thing that is in common is the a. So I'm going to write my 5a out front and then look at what I have left. 40 divided by 5 is 8, and the a's go away. So I have 8, and then I keep the c squared, c squared. 25 divided by 5 is 5. The a's go away. So I have a 5 and a k squared plus 5k squared. Whew. How about the second one? 32bc squared and 20bk squared. So the only thing I can take out of those, 32 and 20 have common factors of 4. So I can divide out a 4. And then the bc squared and bk squared, I can divide out the b. That's my GCF there. So the GCF there is 4b. And then 32 divided by 4 is 8. The b over b goes away. So there's that 8c squared, because I have the c squared left over. And then 20 divided by 4 is 5, and b over b goes away, leaving me with k, plus in the middle, plus 5k squared. Whew. So I have 5a plus 4b from the outsides, and 8c squared plus 5k squared from the insides. All right, so taking out that GCF and factoring things by grouping, we're undoing multiplication here. We're trying to take apart a product and write it in its factored form. That takes us to the end of our notes video for today. Thanks for listening, and I will see you next time.